In the previous video, I demonstrated how to write to a file using files.write and files.writeString. Each execution of these methods is an isolated call which both opens and closes the file resource. These methods might be good for writing data to a log file, for instance, but aren't ideal for writing a lot of records to an output file in an iterable fashion. I showed you another method on files called newOutputStream that returns what's called a buffered output stream. I have the code up where I left off in the last video in the Writing Files project, which also includes a variation of my student engagement types. This code lets me generate a bunch of students quickly, populated with random data. I'll comment out the second to last try-catch block in my code. This is the code that calls a single files.write method. I'll talk about the buffered writer in just a minute, but before I get into that, I want to show you two other writer classes. I'll copy this last entire try-catch code block and paste a copy right below it. With this pasted section, I'll first change the variable type in the try clause from a buffered writer to a file writer. Next, I'll remove that second part of the statement that's on the second line. In place of that code, I'll insert just new file writer, passing that the literal take3.csv, so a different file name for this one. Now, this doesn't compile because the file writer class doesn't have a new line method. I'll remove those two statements for now. Before I run this, I want to set up code for yet another writer class. Again, I'll copy this last try block statement and paste a copy just below it. This time, in this last block, I'm going to change file writer to print writer, both in the variable declaration and in the instantiation. I also want to change the string literal from take3 to take4.csv. This code compiles, but instead of the write method that's specific to writer classes, I'll use a method on the print writer, and that's the familiar println statement. I'll change write to println. Notice that I've kept the first write, the header. This just demonstrates that you can use either of these and mix and match methods if you want. Okay, so now I'll run this and see what I get. In my project panel, I see that three files are there: take2.csv, take3.csv, and lastly take4.csv. I'll open each of these. Take2 looks just like it did from the previous video. Next, I'll open take3. Notice here, if I scroll to the right, we don't have any new lines. You'll remember I removed that statement because it wasn't supported. So how do I add a new line if I'm using file writer? I could just write a \n, for example, but actually there's a better way. Getting back to that main method and my file writer code, I want to insert a new line after the header and after each record. I'll pass a result from a method that's on the system class called lineSeparator. I'll do the same thing after this write statement. This method, system.lineSeparator, will take advantage of the operating system's definition of a new line, which varies by OS. Okay, so I'll rerun my code. Now, all my files look the same. Well, not quite. Did you notice the difference? Take4.csv doesn't have a line separator after the header, and that's because I'm using write and not println. That is one advantage to using println. We don't have to include another statement or include the new line in our string that is output. I'll change write to println in this case. Running that. Now take4.csv looks better. So what's really the difference between these three writer instances? Let me show the differences on a slide. A buffered writer is buffered. With this class, you can change the buffer size, but the Java docs state that the default size is large enough for most purposes. You've seen that we can call new line on this writer. The buffered writer is good for writing large amounts of text to a file. A file writer does has a buffer, but it's much smaller. Java doesn't guarantee its size. It's very common practice to wrap your file writer in a buffered writer. You've seen that this writer doesn't have a new line method, and if we want new lines, our text we're printing should include it. This class could be used for writing small amounts of text to a file. The print writer isn't buffered, but you can pass a buffered writer to it. In addition, the constructor that takes a string actually constructs a buffered writer instance. You can output to a file with the familiar println, printf, format methods, and parse objects to these methods. If you need more control over what you're writing to a file or want to output objects directly, this is a good option. Getting back to the code, I'll use the print writer to write data to a fixed length file. I'll change the name of the file to take4.txt because it won't be comma delimited. I'm also going to delete that simple println statement for the record. First, I want to split each record I get back by commas, so I'll call split on each record. Next, I'll call the writer.printf statement and start with a formatted string, which will specify the different widths for my first 6 columns. I'll start with the printf method and pass a format string that specifies the widths of each field. If it's left justified, I include a hyphen before the width. Many fixed width files left justify text and right justify numbers. Instead of using the string tokens, I can use object by calling get methods on the student, so I'll do a series of calls on the student attributes starting with student ID. Next, I'll get the country code, the enrolment year and month. I'll include age, then gender. I can use one printf statement or a series of them, so I'll end this statement here. I'll start another just to print an experience flag. I'll again use printf with just one specifier for the experience flag. This will be either by y or n. Here, I'll use a ternary against the hasExperience method. I'll next use writer.format, which you'll remember I can use on system.out as an alternative to printf. This time I'm going to use the delimited data for the engagement record information. I can use printf or format interchangeably, so just to remind you, I'll use format. I had encapsulated all the engagement data on student, so I don't really have a way to get the engagement data other than from the record tokens here. I can get the percentage of complete for a specified course by calling the get%complete method on student, so I'll add that here. I'll print the rest of the tokens for the engagement month, year, and type. Finally, I can just call println without arguments to print a line separator. This method makes use of the system.lineSeparator method. Okay, let's run this and see what happens. If I open take4.txt, here you can see that all my data is lined up in fixed width columns. You might have caught that my header is not really in sync because I added the get%complete column, but I'll just leave it as is. This exercise was to show you why you might want to use PrintWriter if you need more flexibility as you print or you don't have access to a pre-processed string for each record. Okay, so these are the basic writer classes you'll use to write data. I'm going to scroll up to the PrintWriters constructor and Control-click on the class name after the new keyword. As I mentioned on the slide, this constructor creates a buffered writer wrapper with a series of nested instantiations. We've talked about the file input stream, and the file output stream is just an output stream for writing data to a file. This is wrapped in an output stream writer, which is a bridge from character streams to byte streams. The other thing I want you to notice is that there's an overloaded constructor for PrintWriter that's a Boolean, and it's called AutoFlush, and here it's set to false. For reading files, I've said that a buffer is temporary storage to reduce the number of disk reads. Data is read in larger chunks and stored in the buffer. For writing files, something similar occurs, so there's temporary storage that gets filled up as writes are executed on a writer class. Physical writes to disk happen when the buffer is flushed. In other words, not every write or print statement you execute is going to be physically written until the buffer is flushed. This is the process of taking the text stored in the buffer and writing it to the output file and clearing the buffer's cache. The frequency of flushing can be affected by a number of factors, including the size of the buffer, the speed of the disk, and the amount of data that's being written to the file. Different writer classes also will flush at different rates. The buffer is always flushed when a file is closed. You can manually flush a buffer by calling the flush method. You might want to do this, meaning flush more frequently when working with time-sensitive data. Any other thread or process that's reading the file won't be able to see the buffered text until the flush occurs. You might be wondering why this printWriter constructor has set its auto-flush argument to false. The default mode for a printWriter is to flush the buffer on every call to a print or format method. Doing this would sort of defeat the advantages of using a buffered writer, so this constructor turns auto-flush off. The buffered writer in this case will control when the buffer is flushed, and it won't be for after every print or format method. I'll scroll up to my code that generates a student list and change the number of students from 5 to 25. I'll go down to my buffered writer block. Here, I'll set up a local variable called count and initialize that to 0. I'll increment count in the nested for loop. I use the modulus operator, so whenever the count is divisible by 5, I'll pause the application for 2 seconds. We'll talk about threads in a later section, but this is a way to make your application pause for a bit. It takes milliseconds, so if I pass 2000, my application will pause for 2 seconds after every 5 records. I'll print a dot so I can watch the status. The thread.sleep method throws an interrupted exception, a checked exception, so I'll use IntelliJ's tools to add a catch clause to my exiting try block. I'll save my code. Before I run this, I'll open up the existing take2.csv file. With this file open, I'll execute my code. There's a key combination that will reload all files from disk, which will help me monitor this file in IntelliJ. On Windows, this is Ctrl+Y or Option-Command-Y on a Mac. I'm going to press Ctrl+Y continuously while this code runs. Notice the dots being printed to the console every 2 seconds. Watching the file, you'll notice right away that the text was truncated and the file is empty. But while this code is running, I'm not seeing any text in this file as I continue to periodically use the reload key combination. After 10 dots, the application ends, and now I can see all the records in my file. The buffer was big enough to contain the 50 engagement records. Now imagine we have another process watching the file that will do something incrementally with 5 students at a time using this file. In other words, we don't want to wait for the buffer to automatically flush with thousands of student records at a time. Instead, I'll flush the buffer manually. I'll do this using the modulus operator again, flushing the buffer after every 10 records. Flush is just a method on any writer class. I'll save this code. I'll open the take2.csv file again. I'll start execution on my main method while I have this in view. I'll start pressing Ctrl+Y regularly. Like before, I'll first see all the text that was there get truncated, but after 2 dots, I'll see 10 records for the first 5 students. After 4 dots, I'll get 20 records displayed, and so on. This demonstrates that the buffer is flushed after every 10 records versus just allowing the buffered writer class to manage it for me. Of course, implementing your own manual flushing will affect performance, so you should only use it in a scenario like this where you're writing large amounts of data, but you want the data to be written out in a more timely fashion, making it available to either another process watching it or some other similar kind of thing. Obviously, this example was manufactured a bit to give you a better demonstration. At this point, I've covered the most commonly used methods for writing text output to files. In the next video, I have a challenge for you, so let's go.